Yeah, we're looking at calculus with matrix. Okay, let's look at the matrix A as a function of t. Okay, then we have this A1 1 as a function of t, A1 2 as a function of t, and it goes on like that onto the last element on 1n as a function of t. Then we have the second row, column 1 as a function of t, second row, uh, column 2 as a function of t, and it goes on to the last element on that second row in column n as a function column n. So we have all these matrices. The last one here, an1 as a function of t, an2 as a function of t. Yeah, so this is the matrix we have, which is the functions of t. So we can get the one. Let's get the differential coefficients respect to t of A of matrix A. This will be equal to what? If you want to find of the differential of A, it's very simple. You just have to differentiate each of the elements of the matrix. That will be A d dt of A1 1 functions of t, and then it goes like that. It goes on like that, and then d dt of the last one there, A1n as a function of t. Then you can go on like that. You can skip it and go to d dt of an functions of t. What we are saying is that if you want to find the differential coefficient of this matrix, you just have to go to the element of the matrix and you differentiate each of the elements. You differentiate each of the elements of the matrix. You differentiate each of them respect to t. Okay? It's not necessarily it should be t, it could be any function respect to that function you are given, respect to the function. Okay, so that's that on the on differentiation. Let's see on integration. We can as well get the integral of matrix A. Integral of matrix A, the t. So in this case now, it's also simple. We'll just integrate each of the elements of the matrix. We integrate it with respect to that function. So that will be integral of what? A1 functions of t dt. Then it goes on like that. Then the last one, integral of what? A1n dt. Then you can come here. Let's omit some values here. So we can get the last one. That will be integral of what? N1 as functions of t dt. Then it goes on like that to the last one, which is what? Nm as a function of t dt. So that's that. Let's see particular applications of these calculus with matrix. Let's see particular applications.